attention, please. Thank you. So a couple of things. This class primarily will talk about the course for this semester, and we will discuss what is expected of me and you. And I will try to show through a little bit Canvas and how we are going to use it. And also I'll show you what type of quizzes I will give you every week. So I'll go through all of this. I would like to spend time on this because a lot of times when we don't go through the material up front, I have students who are asking me much later in the class about specific things, and they say, well, I did not know that, and so forth. All right, so that's why I wanted to take the time today and do this. So I always, what I do in this class, I have taught this class multiple times in this university and in others. And now that Canvas is available, I'm using it exclusively because I think it's the place where you can find everything. All right, I'm not going to distribute anything outside of Canvas. So that is your source. The class, this is a fundamental class that introduces you to electric and magnetic waves in engineering, because my understanding is, I think that you have been exposed to the topic of electric and magnetic waves, but in physics. Is that right? Okay. And I also understand that that may have happened a year or 2 years ago for some of you, and the material may not necessarily be as current as it should be. So this first week, we will do a review of what is fundamental for us to remember, at least for the first part of the semester, and then we'll talk about the second part. Now, I have taught this class multiple times, and over time, I have started thinking differently about what I, as a faculty member, expect of myself in terms of what I'm going to help you learn and what I expect of you. And I will just talk a little bit about this. Early in my career, when I was an assistant associate professor and so forth, at the time, obviously, I was not the only one, but everybody was teaching a class. And somehow we thought that the grade was like the goal, all right? Your goal, our goal, and everything was like revolving around it. So you had specific activities that were taking a big part of the grade. So practically the midterm, homework a little less, at the time much less than the midterm and the final. So over time, the last 5, 6, 7, 8 something years, why I want to stay in a university and teach, because I had options to go to industry and I never entertained the idea because I like the university. So the goal of teaching is not to give you a grade, all right? The goal of teaching is to help you learn specific things. The grade is an outcome. So the grade is an assessment of what you learned. So what that means is if a grade depends on your performance over a short period of time, I think it's a failing grade. Failing from the point of view, the way we have calculated it, because a lot of times some individuals can perform to their capability over a short period of time. Some others don't, all right? Especially in the early stages of learning something. We don't necessarily be timed, all right, to see how fast we can respond to a question. That is no indicator of what you know. So also my career has taught me the following, that by the time you come here to take this class, you all have gone through a lot of filters in terms of your abilities. So I'm not testing that, all right? You are all at the same level in my mind. You are all equally smart. You're all equally capable. You can write, you can read, you can think, you can do all of those things. At this moment, what is going to differentiate you from your colleague is how much time you're willing to spend on a topic that you have to learn. That's all that differentiates us, nothing else. Don't believe that there are smarter people in this class than others. That's not true, all right? That is not true. We as faculty, as a matter of fact, there was a time when we were making fun of ourselves rather, and we were saying that, okay, the A students became faculty and the B and C students became CEOs and made money. All right, that tells you, all right, that tells you that everybody was smart. It's just that our interest was different. Now we don't say that anymore because somehow it was demeaning for the faculty. So the bottom line, however, is that is exactly what I said. All right, I have seen undergrads who got an average grade as an undergrad. In fact, I had a graduate student whom I recruited as an undergrad because she was extremely smart. But her grade was not necessarily a grade that I would consider as appropriate for graduate school. In graduate school, she graduated with a 4.0 from the University of Michigan, and now she's a vice president for AFIO. So grades, what that tells you is that the lower average that she got as an undergrad was because at the time she was not spending enough time learning the material. But when she got interested, then you could all see the capability. So the amount of time you will spend and the effort to learn is the differentiator, number one. Number two, now we know a lot more on how we learn, all right? Not before, definitely not in my generation when I was going to college or schools in general, not even my generation as a faculty member in the university. But now we know that repetition helps us learn. And as a matter of fact, I did, after we had access to Canvas and eCampus and so forth, Canvas primarily, because it's been many universities, I did some statistics. And what I found is that students who spend a little bit of time every day revisiting the material, let's assume 1 hour every day, somebody, for example, half an hour every day, revisiting the material that we covered in class, like say 5 days, half an hour, 2.5 hours, that's better than somebody else who waits until Sunday to spend 5 hours to learn the material. And why is that? Because that's how our brain works. Our brain has limited memory. So what does it do? It takes the information, processes it, all right, from all the senses we have, and then stores it in what we call the working memory. Very important. Then, if you go to recover this information in a short period of time, because this working memory is not permanent memory, it's working. If you go for in a short period of time to recover it a few times, then that piece of information becomes part of your permanent memory. If you don't, then the brain deletes it. It's not like, you know, in the old days we thought, oh, it places somewhere, but we don't know the registers, you know, from there is nothing like that. It does not place it anywhere. And that's why, like I do right now, I open books where I see my notes next to it from when I was in school, and I have no idea who read that book. I said, did I read that darn book? I mean, my handwriting, all right, obviously. That's what happens, all right? So if you learn something in class and you revisit it even for a short period of time, you're gonna do very well in this class because you're gonna keep the material current. If you don't, you will have to relearn it. And that's like not the right way to do it. You know, it's like you have to spend time over and over again to learn the same thing and then forget it and then relearn it and then forget it. So keep that in mind. Now, to help you do this, I give some kind of, like I give a quiz. So you're gonna have one quiz on Monday, which is on Canvas. one quiz on Wednesday. So I have a quiz today. So I will in fact show it to you. So if you go to quizzes, there is a quiz. For the quizzes, this is a review. For the quizzes, you're gonna have, so if I will make it available today, I think it's a 2 for both classes, then you will have until like before the next class to do it. So it's not like that you're gonna have 10 minutes, 15 minutes. You can, it's not for me to get a grade from that, it's for me to help you do a little bit of work. It's light work, but you cannot believe how much this light work helps. So in this one, for example, which is a review on vectors, if you go on a preview, what it's gonna do is asking you different questions, all right? And then it's a multiple choice. So you will respond, it gives you, if there are 3 problems, it gives you 30 points for the 3 problems on the basis of responding accurately. But then at the end, so there is a fourth, not responded, there is a fourth question. Always there is going to be the same fourth question that says it's a true and false, and that gives you another 30 points. By responding to that, this is only for participation. So you get 30 points for participation, 30 points from those quizzes for correctness. So these quizzes give you 60 points, but there are many. So that's the other thing about the class. All right, you're going to have one on Wednesday, one on Monday, Wednesday, Friday. Normally we'll do either a review or we'll do other things. And then over the weekend, you're going to have homework. Homework is going to be given to you every Sunday at 6 p.m. and it's going to be due the next Sunday at 11:55. Now, guess why it is 11:55? Because everybody was asking me to do it as late as possible, and that's the latest, 5 minutes before Sunday is out. So you're going to have to submit it. You're going to always be able to submit it. And I will always be able to see how late you are. Now, I would like you to be on time, obviously, all right? So I may penalize you for being late, depending on how late you are. It's up to me, and I will do it on an individual basis on what I see. The other reason I do that is because sometimes people are sick. All right, obviously, or have other commitments, and they ask me ahead of time whether it's okay to delay. And I say yes, but that's not for everybody and does not happen all the time, and you're not going to know it. So the best thing is if you are capable to submit your homework, and if you have no reasons to not submit it on time, please do it. Okay. Now, if you get homework, you're going to get homework every week on Sunday, and it's going to finish the next Sunday. And you're going to have the homework corrected within a week from graders. I'm going to put the solutions of the homework, not immediately, because sometimes people are sick and I don't want to create different homework for different people. But I will do it as soon as if I don't hear from anybody having any problem, I may do it on Monday morning. If I hear somebody has a problem, I may delay it for a day. I'm not going to announce it though, all right, to the rest of the class that, oh, there is a student and blah, not well. So you know that my solutions will be within a few days uploaded. From the moment I have uploaded the solutions, and then after that you submit your solution, I'm not going to even grade it. I'm not going to tell you why. I may put like a note that it came after the solutions were posted. And this is not going to be graded, all right? So you know that. Okay. Now, the other thing in this class, we have teams. And that's something you need to do. Why do we have teams in the class? Your homework is going to be given to you. Usually every homework has 2 problems. I mean, if I give one homework, it's going to have 2 problems in there. Maybe multiple questions on that problem, but 2. Now, instead of giving you 2 problems in one homework, I give you an individual homework that has 1 problem, and then a team homework that has another 1 problem. Why team? A lot of times we learn a lot more when we talk with our colleagues about a problem. Do you remember what I told you? For me, I don't want to, my goal is not to give you a grade for the homework. My goal is to use the homework so you learn. So in teams, you will be able to work together and identify the solution to the problem, all right? Work together. However, even if you have worked the solution of the problem together, I would like all the members of the team to submit their own, to write it down individually and submit it. Why is that? Because unfortunately, a lot of people under a lot of pressure, having many other courses and stuff, may not necessarily submit. If I don't do it like that, there were students in the past who did not submit anything and got a grade from the rest of the team. And the rest of the team gets really angry because this person got a grade for free, all right? They never show up in the discussion. They wait for the team to submit one solution. I did it one semester and I regretted it. So now you are free to discuss it. Of course, I would like to encourage you to discuss it. And then write it down and then submit it individually. And the grades you're going to get will be individual grades, even if you're members of a team. And why is that? Because it is possible that one team member will not submit a solution. All right, it will be fair that this person will not receive a grade for that if he does not submit a solution. So I also decided this time, in the past, I would assign students to groups. And then now we go to people. So on Canvas, so I avoid having two separate, there are two sections in this class. As you know, both of them have a lot of students. Instead of having two separate Canvas websites, and I will miss things from one or another, I decided to merge the Canvas for all the sections, but I keep track of who is coming from what section, because we have honor students, we have 501 and 502, all right? Now, the homework for the two sections will be the same, but midterms and finals will be different, okay? They're taking place at different time, and of course they will be different. But homeworks and quizzes will be the same because there is a big overlap between the two classes. The material is going to be the same. Now, in this, I have created teams. Some people have already assigned themselves to teams. Because we are about 180 students between the two sections, I have created 45 teams or so. And please, for those of you who know who are the members of your team who would like to work together, please go and sign up. Make sure that your team has only members from your own section. The reason for that is because I cannot enter grades for you if you do, like, for example, when I will give a midterm, I will give a midterm according to Canvas. I can give it only to one section. I mean, it's identical midterm, I can give it to two sections. However, since the midterms will be different, because it will take place different times, then 501 is going to get, for example, one midterm, 502 is going to get a different. But your grade is going to come only because Canvas is like that. As I will grade your uploads, I will only see it under one. So let me, and then I will not see it on the other. So let me explain what that means. I had a student 2 years ago, without telling me, moved from one section to another, took the midterm and everything. Of course, the class was very large. I had no idea that this person moved, but I could see that this person had not taken a midterm and a final, because when I was looking, I don't know where his uploads went. Obviously, they did not go to the place they were supposed to. And at the end, of course, I failed this person. I showed that he never showed up. And then when he came back, and eventually we did all of this and we found his work, I mean, he was in a different section. So don't do that. all right? Stay with your section, find others from your section, put yourself in a team. If by Monday, before the class, I have only a few people have signed up themselves in teams and the rest of you are not, you don't care, you don't know too many people or say whatever, then I will assign you randomly. So by Monday afternoon, everybody's in a team, all right? Because Sunday you're gonna receive the first homework, it's gonna be a review homework, obviously. And the review is gonna be on vectors, on coordinate systems and relationships. And then of course, the homework is gonna be like some discussion about the 4 forces of nature, all right? And so that now brings me to what material you should use for the class. In the past, I've tried different books and I did not like any one of them because they use very weird notation that is not, especially it's very difficult. So you have a book, people have written those books many years back. First of all, they're kind of outdated in many ways, even if electromagnetics is not like, it's not like technology, all right, that is changing, but even outdated because of the way we teach things right now. Second, different books use different notations. And some of them are fundamentally different to the point that if I get one chapter from one book and another chapter from another book, then we are gonna all get confused. So what I decided, I will use what I call my text notes. It's not a textbook, it's a text, they're text notes. And my text notes, so go to modules, you're gonna see them under modules. So they're going to be here. I have created 3 modules. And then also you're going to find them under every week. Okay, here. Now the week overview, I will still complete those. I will complete the week overview after Friday, of course, every week. All right. Towards the end of the week, I will just remind you what you have to finish. So everything is correct up to here, up to what it says for week 1, text notes for week 1. And if I go to this, they are my own notes that I have. Let me see, they should come up. There. You should be able to download them. And this is on the forces of nature. We'll talk about those. And today, hopefully, we'll just, I will explain why I started with that. And then the next one is on coordinate systems. And coordinate systems, what I wanted you is to remember of the Cartesian of what happens to the spherical. There is a problem here with the figures, all right? So I need to go and fix it. One figure went for some reason to the wrong place, but the equations are correct. Convergence between coordinate systems, all right? So all of this is material that you need to not memorize, but have available when you need it. And the final thing will be vectors. Now, vectors are also important, and you have seen those, all right? Also, the fundamental things about vectors are here, but I have done them in a way that using notations that we are going to use throughout the class. Now, since I'm writing the notes myself, it is very possible, even if I check them, it is like the figure now moved around. So if you find anything else, let me know. If you find any, not typos rather, grammar and stuff, I think that might be okay. But if you find any notation, something that, let me know, and I will have like a little piggyback with, piggyback is gonna have for this class, extra credit. Every time you find a good correction, for the notes, then I will give you a few extra points. And I will put it in the biggie bag, and then we're gonna go and get those extra points at the end when I will be ready for each one of you, obviously, when you're gonna be ready, when I will be ready to get grades. So there will be not too many, but they will be useful. And I would like to do that because I recognize that for those who really pay attention to what I'm doing and they correct me, that's a good thing. So please feel free to do it. And I will be very thankful for that. So I will also, when you go to your Canvas and you look here for course resources, which I think so if you do course resources, you will see that in those I have, of course, again, the notes, so you find them wherever you go, but also I will have some references. If you want a little more beyond what we're doing, all right, obviously, this is a good book to go for reference. Now, references, as you and I know, all of us are looking at Google for references. I would like to warn you on something. For me, going to Google, it's safe because I know what is right and I know what is wrong. When I see something that is wrong, I know and I go away. Usually, I do not rely on websites where people ask questions, somebody responds. You don't know who is responding to this question. It might be a very knowledgeable person. It might be somebody who really gives you the wrong answer. The most safe websites will be presentations or lecture notes from universities by faculty, all right? I will not trust too much a YouTube unless it's done by a faculty member. There are a lot of students who create YouTubes. I would not trust those very much. You know, I mean, take it what you see, but check it out, all right, always. Because everything that we are gonna do in this class, from including midterm and final, will be open book, open notes, open everything. You can bring your laptop, you can bring your iPhone, as long as you don't pay somebody to do the solution for you. I have no problem. However, you're gonna be responsible for the correctness of the answer. Don't tell me that's what I found on YouTube or that's what I found on Google. That's not my problem. If it's wrong, it's your problem, all right? Because in fact, this is another way to learn it. Don't trust and confirm, whatever they say. Trust something, but also make sure that it is the right one, all right? Don't approach everything with lack of trust. That's not a good quality to have as a human being. However, you have to make sure that everything that you see and you believe is correct, it is correct at the end. So it is up to you to do the right work that is required, all right, to make sure that what you hear is the right thing. Okay, that's about notes and other things. I will pause a little bit at this moment to see if you have any questions. Any discomfort with any of this? Now is the time to talk about it, not later in the class. Okay. Office hours. I will have office hours after, and so before I go to office hours. Immediately after this class, the class ends at 40. I have the same section, the second section of this class starting at 3 in a different building, which means I will not be able to stay here too long after the class because I will have to pick up my stuff, go out, I have to go to block, and then go there, set up my stuff again for another section. So if there is a very brief kind of question, you can ask me, but 5 minutes after the class, I will be out of here. Now, I have office hours Monday and Wednesday from 4:30 to 6 online, and Sunday from 2 to 3:30 online. And you will find those here where it says Zoom Pro 1.3. It has all the Zoom links for all the office hours, okay? By date and by time. So today, however, we are not gonna have office hours because I have to go out of town and I'll be back on Friday morning. So our classes will be there. But these are the office hours that we will have, and I will let you know if for some reason something happens and I may not be available, I will make it up, especially when we start with homework and I know people will have questions to ask. Now, there are a couple of times in February that I will be out of town for university. I have to go to 2 workshops for research that they have invited me to. I will let you know ahead of time, but for those classes, I will record my lecture. And you're gonna be able to listen to my lecture from wherever you are. You can come to this class if you wanna listen it from here or from home. But I will let you know ahead of time what those dates are, right? So there's not gonna be any disruption. I'm recording our lectures, but they're not gonna be available to everybody. The reason I'm recording lectures is because we have a few people who have listed a disability and who need the recordings. Why am I saying that? Because don't rely that you're going to have a recording and you do not show up in class. So I'm telling you though, what is going to happen, unfortunately, to this class, if I extrapolate from the past, because that's the only data points that I have, it usually starts like that and it thins out. In this class, if you do not come to class, do not participate, you don't hear what is happening, you're going to find it very hard to follow. All right, so keep that in mind. I know there are a lot of pressure. Some of you may have 3, 4, 5 courses. I had students in a class last semester with 5 courses. And it created a very difficult time for me and them. I could not help them. I mean, there is so much I can do in a class of this size to help individual students. I will do the best I can, really. But come to class. Don't think that it's gonna be a ask me after the fact, or like now I was working into class, somebody sent me that they got sick, they cannot come. Okay, I understand sickness though. I get sick too. Everybody gets. But, and that is something that the university can. But if I want to go with university guidelines, I will ask for something. I don't do that, all right? Usually I don't like to be the police here. That's not my role. I will never act like this. I will trust you in everything you tell me, even if I know that it might not be true. But that my role is to help you do the best you can, to give you incentives to do well. You're not gonna fear me in this class because I don't think we learn this way. I don't learn when I'm afraid of something. I only remember the fear I had, but I don't even remember the reason why I was afraid. But I remembered that I was afraid of something. I did not, that reason was not recorded. But so in any case, I think we are adults here, so I will do the best I can to help you. But as I said, you need to help yourselves, all right? So I think more or less this is all that I had to cover in terms of how this class is gonna run. Is there anything else that you think I have missed? If I record them. So here is the problem about the recording of office hours. I'm not, even when I record, say, a session, I can only record myself and I have then to edit it. to remove names and the time when other people speak. So I don't record office hours because there is a lot of interaction with students, and I cannot, then I have to remove all of this. What I do, however, there will be times when we will do review. I record review sessions because most of the time I speak, all right, which means I solve problems. But other office hours is when people come to ask questions. I do not necessarily record those. Now, if there is in office hours, this is on Zoom, everybody's there. I don't have people waiting in separate rooms because it gets a little chaotic. So everybody comes in. So if you can come ask questions, I think everybody else is going to benefit from your question rather. But if something is personal, you need to discuss with me, then you send me an email and we're going to meet in person or on Zoom, but individually. All right, so that's how we're going to do. All right. So since we covered everything for this class, now I would like us to start a little bit with the material. So I'm not going to spend too much time on vectors and coordinate systems. These are things that I'm sure you know, but please review it. Because the biggest problem that I have seen when we try to solve problems in electric and magnetic fields specifically is that, and as you know, these are three-dimensional structures, especially when we talk about distribution of charges or currents, then they flow, and we try to understand the fields that are produced either by charges, static charges, or by currents, steady currents. Unless you have the ability to see things in 3D to be able to conceptualize, it's going to be very difficult to solve some problems. All right, so try to go back and at least try to understand what happens with the coordinate systems. I try to do some things in 3D, both for the cylindrical and the spherical system. Now, the one thing is how you transform from one to another. So we'll probably, as we do the material, I'm not going to spend time on this because a review of these two modules, but as we do work, say, in electrostatics, then I will review some of these, all right? When you have two vectors expressed, for example, in a spherical coordinate system, and then you need to sum them up. How are you going to sum them up? That's a question, all right? Are you going to just do this? Where is it? Here, for example, you have a vector A. You see that? A. Can you see from there? Maybe not. Next time I have an iPad, I'm going to write on the iPad. But let's assume that you have a vector which is in the spherical system. Has R sub A. Then it has theta sub A. And then it has phi sub A. Okay, these are the three coordinates of the spherical coordinate system. And then you have another vector B that has R sub B, theta sub B, and phi sub B. Okay, then I wanna sum them up. In Cartesian coordinate systems, how do we sum up to when I have, so for example, if I had two other vectors, C, which is a function of X, Y, and Z, and D, which is a function of X sub D, Y sub D, and Z sub D. How do I find the sum of the two? I add X C plus X sub D, Y's, and Z's. All right. Do I do the same for the spherical? No. Well, you will be surprised that people do. If you don't review, then you think, okay, well, if I do this here, then I will be able to do it at the spherical. And of course, this is incorrect. if you want to sum those up, either you're going to do it graphically, which I have it in my notes, or you're going to transfer this to the coordinate system. You're going to have to make a transformation in the coordinate system and then do the summation of the coordinates. These are important because you cannot imagine how many people make mistakes there. So that's another one. Oh, that brings me to the last thing that I was important. We also, in talking about coordinates, I'll come to the other side. In absolutely we roll things, all right? For example, you may have a sphere, part of the problem, and then you may have all positive charges distributed in this sphere. Right? And they ask you, they can see those things to write how the field is going to be, the field lines, electric, electrostatic field. That. All of the lines are perpendicular to the surface of the sphere. All right. See, I do this by hand, but the quality is good enough. So it shows, for example, what is happening. Okay. In my class that I had last year, especially in forward because they were, I would get something like that. That's not acceptable. That is engineering decay. All right. That means something to us. The fact that this goes here means something. The fact that you can draw like that. I mean, engineering drawing for the old days, people were spending classes on engineering drawing because now you do it with AutoCAD or you do drawing with PowerPoint, but engineers do not write cartoons. This is a cartoon. I mean, I was in fact thinking and put it like this. So seriously, I saw that in the student beginning of physics when I did that. I said, this is a cartoon. So please, when they started to put scary for us, they think, without this, if they found it, I would roll back. I would go and face like that. And I would return it back. But please remember that, right? Remember it. Of everything you do it with engineering clarity. An engineering drawing or figure is meant to provide information. It's not a visual thing. All right. So now I gave him the opportunity to talk about that. All right. So let's talk a little bit, which is fun, as a matter of fact, to talk a little bit about forces of nature. How many forces does nature have? It says here, obviously. Let me see. I want to increase that. Let me see how I can do that. View 4. Was that?
Go into the slide and scroll up. It's just kind of
Here. Okay. Anyway, what I can do is I can go to my notes, as a matter of fact, get out of here. 1 second. Okay, I can go here. And I can go here. And I can do here. And, or in fact, not that, this one. And then I can increase this. Okay. 4. These are the 4 forces of nature. You know that, isn't it? What do you know about these forces? What is really characteristic of each one of them? Why do you think I'm putting emphasis on something that you may not see again in this class, because we are going to really focus on this. But why am I interested in understanding the forces? Why is that? Because in this class, we are not going to just memorize things. We are not going to learn recipes. In this class, we came on an engineering background to understand how nature works. If we understand how nature works, physics, the fundamental physics behind things, first of all, you're never gonna forget it. And then second, it's going to allow you to do a lot of things outside of everything that you have seen as part of your coursework. So I will emphasize a lot more understanding of the physics than solving an integral. And why is that? Because yes, at my time, I needed to know how to solve an integral because I had to do this myself. There was nobody, there were a few books that would show you integrals, but if you have to integrate to find, say, an electromagnetic field, I had to do the integration. Now, guess what? You go on the web, you find any software that will allow you to develop any kind of mathematical function and manipulate it accordingly. You can differentiate it, you can solve linear equations, you can do all kinds of things. So why would I spend my time teaching you math instead of teaching you what to see beyond math? Math is like a language, all right? You know it. It's like, or you have translators right now. What I would like you to do is to understand beyond math, what that tells you physically. That is important, all right? So it is important to put this force in the context of everything else. And to ask yourself, you know, do I feel this force? Well, if we feel that, all of us, all right? Now you're sitting down because thank God, otherwise you will be somewhere there. We'll look at you. But do you feel that? Do you have any, can anybody tell me the result at least of these in a way that I can understand it? If that for a moment did not exist, let's assume that everything else existed here, but God came over and pulled this out of nature. What would happen to you? Do you know? You will go through your chair because, why? Because the atoms could not hold themselves together. All right, what holds an atom in place is this. And if for a moment, let's assume, and I hope not, that somebody takes this away, we are going to be decomposed. All of our atoms will under these and under those will just cease to exist. Or if your atoms do not flow out, you will probably see everything go through the chair. All right, so that is this one. Gravitational. Do you, as a matter of fact, no? So let me ask you this. So this electromagnetic force holds electrons and the nucleus together, all right? And you know this, like what we call the Bohr representation. It's like the solar system. You have the center, the nucleus, and then you have electrons that go. But in reality, an electron, even if it has a mass, we think, it's like a cloud of energy, all right? An electron represents energy. We cannot pinpoint it, even if people have started thinking that that is not true. But Heaviside has said that the more you try to find the location of an electron, the more you lose the capability to do that. All right, so it is energy. Think of that as energy distributed, and maybe energy with a distribution, where the distribution, if it's a Gaussian, it means that you have a better chance of being in that place, but in reality, it's energy. All right. So, however, for simplicity, we think of those flowing like the planets, but they are all of these electric forces that hold the electrons of that energy of electrons connected to the nucleus. Okay. That now, and the gravitational, they are forces that operate at different scales. All right. So, for example, we are attached to the surface of the Earth because Earth is a huge mass and attracts our mass. All right. So we have a weight due to gravity. But this one does not apply with these kinds of long distances. This electromagnetic force, you cannot feel it. You need to come really much more smaller distances, like an electron from a nucleus, to be able to start seeing that, where the gravitational force is not important anymore. Do you know of an example where the gravitational force starts fighting the electromagnetic force in a big way? Where? Well, yeah, like the black holes, all right? Where if the gravitational force destroys that, and practically you have a mass, what happens is that you have mass. So there is so much density of mass that applies to every scale. And then if there is a mass, then it's attracted so much that destroys the electromagnetic force and then becomes energy from the other side. So there are in space, I mean, space is very, it's how do they, the right word, it's not a very place, a very nice place for people. It's very violent, all right, for us thinking that you can have this destroying that. However, on Earth, all right, those two are totally different. This one is what important for. This is important for fusion. All right, the weak force is the one that creates fusion. Fusion is like, it's not exactly a force, but it's when practically you have a nucleus then that is split into a neutron and some other particles. All right. So, and then the strong nuclear force, we see it in the sun. All right. So that is a force that practically applies even within the proton. All right. Within, so if you think that we live in a space that starts from plus infinity in scale, all right, to minus infinity, yeah, it's a continuous thing. And there are no limits to the sizes on the big end and to the sizes on the small end. People still find particles that are very small. So this is important to understand because it gives us a sense of where we are and what we are looking at. All right. And in our, in the space of our observations, this is sitting there by itself, is responsible for the use of this, is responsible for the use of my computer, right? We have found ourselves in a space, in a very thin slice on this scale of sizes, very thin, where this one is independent from this, is independent from this, and is independent from that. And we have been able to use it because of this effectively, without destroying ourselves. So we are going to learn more about this and how we implement it to do things, all right? And I would like, in fact, to look beyond the map. So please, you will have a need, and I have to leave immediately. So you will have a need to review, all right, the things that you have seen before, so we have more time to go forward. Okay, so I will see you on Friday.
You did? I did. I did hear that. Yeah, I let the founder focus on we saw with the bishop to the higher. I didn't miss you my phone, so I
Yes, I'm doing this while I can hear you. Tell me. Oh, that's not, where did you check? Where have you laid that? No, don't look at the assignment. Look at, this is only a template from Canvas. But look, go to home.
Cool. All right, I'll see you around. Yeah, yeah.
If you want to see the quiz, you go to quizzes. You see the quizzes there. Okay, go to that. That's where it is. Don't go down here yet. In the assignments, I have to fill when the first homework, I clean up that thing. It's a template.
Thank you.
Sure.
Are quizzes only one attempt or are they unlimited attempts?
The quiz, multiple.
Oh.